Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, in our today's lesson, we will discuss about the Dalton's law of partial pressure. So, basically, that law was proposed by the John Dalton, and John Dalton just studied about the mixture of gases, and he just put forward this law about the gases and their pressure. So, according to this law, definition is the total pressure of the mixture of gas is the sum of the partial pressure of each gas. So simple mean is this: when we have a mixture of non-reacting gases, or non-reacting gases mean the gases that do not react with each other, or the gases that are inert towards each gas. Then the total pressure exerted by all the gases is equal to the sum of partial pressure of the gases. Partial pressure of the gases. For example, here we have two cylinders in which we have the pressure P1, or the gas is applying the pressure P2. Then the total pressure will be the sum of pressure of the gas 1 and the pressure of the gas 2. It means when we combine the gases, then the total pressure will be the sum of their partial pressures. This was a simple law that is known as the Dalton's law of partial pressure. So how we can calculate the partial pressure? Let's have an example for this. The first one example, here we have a mixture of gases where we have oxygen gas. It is applying the pressure 20.9 kilopascal or 3.03 psi, and the nitrogen, it is applying the pressure 78.1 kilopascal, argon applying 0.79 kilopascal, water vapors applying 1.28 kilopascal, and the carbon dioxide is applying 0.05 kilopascal, and below are the units in psi. So the total air pressure is 101.3 kilopascal, or we can also write it as 101.325 kilopascal, which is equal to 1 atm, or 1 atmospheric pressure. This is also equal to 760 torr. It is also equal to 760 millimeter of mercury. It's mean the total pressure of the air in our atmosphere is 1 atm. Then when we just combine the pressure of all the gases separately, that is the mixture of gases, oxygen, nitrogen, argon, water vapors, and carbon dioxide, it is equal to 1 atm. So the pressure that these gases are going to apply are known as the partial pressure. And when we take this pressure P1, P2, P3, P4, and P5, so here the total pressure PT is equal to P1 plus P2, P3, P4, and P5. So this is a simple explanation of the partial pressure, or the Dalton's law of partial pressure about the gases. It is equal to the pressure applied by all gases. Next, we have the derivation of the partial pressure of the gases, how we can calculate this. For this purpose, let's take the three cylinders. When we just take three cylinders, the cylinder number 1, 2, and the cylinder number 3, and in all these cylinders, we just fill the gases, and their volume will be 10 dm cube, 10 dm cube each, and we take the gases. The number one gas we take, it is hydrogen. The second we take, it is methane, and the third one we take, it is oxygen gas. So let's have a look on its partial pressure. The first one gas, which is hydrogen, its pressure is almost 400 torr, and the pressure of methane is 500 torr, and the pressure of the oxygen gas is 100 torr. So when we are going to add this pressure, the total value we gain it is 1000 torr. So the PT is equal to the pressure applied by hydrogen, then the pressure applied by methane, and third one pressure applied by the oxygen gas, which is equal to 1000 torr. As all these three gases are non-reacting and they are behaving independently in the given conditions of temperature and pressure. So as they are moving rapidly and they have the equal opportunity to collide with one another and with the walls of the container. So when they collide, then they apply the pressure and the total pressure will be equal to the total number of collisions. So here we have one result. The total pressure will be equal to the number of total collision that these gas particles will have with one another and with the walls of the container. So the molecules are moving independently. What type of result we gain from there? As we have the general gas constant or equation PV is equal to nRT. Here, the number one we have pressure of the hydrogen gas, and which is equal to the number of moles of hydrogen gas and into R and T. After we have the pressure of the methane gas, its volume, which is equal to number of moles of methane that we take in the container and R into T. And then we have for oxygen gas, its pressure O2, volume, number of moles of oxygen and R into T. So by rearranging this equation, we gain pressure of the hydrogen gas is equal to number of moles of the hydrogen gas RT over V. Then for the methane gas, its pressure, which is equal to number of moles of methane and RT over V. And then we have for the oxygen, pressure of the oxygen or the partial pressure of oxygen volume, which is equal to number of moles of oxygen and RT over V. As here, the RT over V, RT over V, these are the constant. Then the equation we gain from there is the partial pressure of hydrogen gas is directly proportional to the number of moles of hydrogen, and the partial pressure of the methane gas is directly proportional to the number of moles of methane, and the partial pressure applied by the oxygen, it is directly proportional to the number of moles of the oxygen gas. Its mean as R T over V of each gas is constant, then what we gain the result as the total pressure is PT is equal to pressure applied by hydrogen plus pressure applied by methane and plus pressure applied by the oxygen. So by putting up these value, we just gain number of moles of hydrogen plus number of moles of methane and plus number of moles of oxygen. And here the RT over V ratio is a constant value. It's mean at the end we gain PT V is equal to N T total number of moles and RT over V. So this is the basically law of partial pressure that was proposed by the John Dalton. So he just put forward that the total pressure applied by the gases is equal to their number of moles. So this is all about today's lecture. I hope you guys understand, and if you have any queries, you may ask me about that in the comment section. And the next topic that we will discuss it is the calculation of the partial pressure of the gases. So for that time, you guys keep learning and have a good day.